Hello, I'm Alexander Lewis, and today we'll be solving this problem. We'll rotate the region bounded by y equals 4x and y equals x cubed. Assume that x is greater than or equal to 0, and it will be rotated about the y-axis. Okay, so the first thing we did was draw a graph to see what area we'll be rotating. So this little arrow circle here means it will be rotated about the y-axis, and these are the two graphs. Y equals x cubed is this curvy one here, and the straight line is y equals 4x. The area that we will be solving for and rotating is indicated here and by the lines. Okay, so the first thing we want to establish are the bounds. The bounds are the x-axis, because x is greater than or equal to 0, therefore one of the bound is the x-axis, and then the two graphs. The second thing is we are rotating about the y-axis. Okay, so in order to decide what method we'll be using to find the volume of the solid formed, we have to figure out first how the variable of integration relates to the axis of rotation. So in this problem we have f of x rotated about the y-axis, so the variable of integration is x because it's the function is f of x, and the rotation is about the y-axis, so we're going to use the shell method. So we start off with a 2 pi times the integral from 0 to a. We have to figure out what this upper bound is, so where a is the x value of the intersection of the two graphs up there. The intersection to the farthest right, which will be the upper bound. So here we have x, we set the two functions equal to each other, x3 equal to 4x, and we find that x equals 2. So our upper bound is 2. Then we just solve for the integral. We have x, which is the radius. It's x minus axis, and the axis is 0, so it's just x, multiplied by the upper function, which is 4x, minus the lower function, which is x cubed, dx. And you take that integral, and these are the following steps. So you multiply this x into each factor, so you come up with this. Then you take the integral, and it is 2 pi times this, evaluated from 0 to 2. And since when you plug in 0, you plug in 2 for the integral, and you have this, and then you subtract. This is 0 because when you plug in 0, it all comes out to be 0, so it's just minus 0. And then the final answer is 2 pi times 32 over 3 minus 32 over 5.